Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and this week I'm going to continue my discussion about HVAC at high altitudes and talk about water coils. So last week I covered that even though a CFM is a CFM at all altitudes and temperature, the heat transfer capacity changes depending on the density of air. So I'm going to talk about altitude in today's podcast, but temperature will also affect density. So at altitude, where the density is lower than standard air, which is how everything is cataloged, the heat transferability will also be reduced. When you use a coil selection program, it usually asks for CFM, altitude, and entering air temperature. The selection program isn't using just CFM for its calculation though. It's really looking at pounds per hour passing over the coil. This is called the mass flow rate. And let's call this M. To get this, it converts CFM to pounds per hour, where the mass flow rate, M, equals the density times the face area of the coil times the velocity of the air moving over the coil. And if you recall from one of our previous podcasts, area times velocity is CFM. So now that we know how to convert CFM to mass flow rate, we can look at the equation for the heat transferred to the air from the water coil, and that's Q equals M times the change in enthalpy. So if you tell a selection program you have standard air, it's going to use sea level and 70 degrees Fahrenheit to get the density, which is 0.075 pounds per cubic foot. But let's also compare that to if you're in altitude where your density is 0.06 pounds per cubic foot. So let's put this in the equation here. We'll say the heat transfer for standard air, 0.075 times the area times the velocity through the coil times the change in enthalpy. And then the heat transfer at this altitude is 0.06 times the area times the velocity times the change in enthalpy. So without putting any other numbers in the program, if everything else is equal, you can tell that QS is greater than QA. So that at altitude, you'll get less heat transfer through the same coil at a given CFM. So if you need to increase your heat transfer at altitude, you'll either need to increase your area or increase your velocity. So you can increase your area by using a bigger coil, and you can increase your velocity by using a higher CFM. Luckily, selection programs will help you select your coils at any altitude because you can input this information, but it's good to have a basic understanding of how altitude affects density and how that affects your coil selections. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.